So your starter is, if you were to march 10 meters to the east, 20 meters north, then 14 meters west, then 23 meters south, how far and in what direction will you be from where you started? Okay, so let's draw a picture of it. So we'll do given. Okay. All right, so I'll just start right here. And it's good to draw a little picture of these things. It says, all right, 10 meters to the east. Now, remember that north, south, east, west. So to the east is like the positive x direction. So we're going to go 10 meters to the east. I just say, okay, that's 10 meters. I've just decided that that length is 10 meters. And then from here, you're going to march 20 meters north. So that'd be twice as long. So there's 20 meters. And then we're going to go 14 meters west. Oh, I didn't plan this very well, did I? 14 meters, well, this is 10, be 4 more. Be right there. So there's 14 meters. And then, and I think I drew it a little too long. And then 23 meters south. Something like this. So we want to know, well, here's where I started and here's where I ended up. So I didn't really go very far. So it'd be down here somewhere. And that's my answer. Okay, and that's what I'm looking for. I'll just call it R for resultant vector, the result of doing all that marching. So that's what I want to find. I want to find R. Now let's solve it. And I could call this, vector A, vector B, vector C, and vector D, and add them together. I'm just going to add 4 vectors here. I don't think I'm going to bother with that because it's really kind of not necessary to do that. But what I am going to do is I'm going to put each vector in rectangular coordinates, and I'm going to add them together in a column. So the first vector is 10 meters. And remember, this is x, and this is y, and 0 meters. See, this goes 10 meters in the x direction and 0 meters in the y direction. Plus, now what is this? 20 meters, but in the y direction. So this will be 0 meters in the x direction and 20 meters in the y direction. And then here we have 14 meters. But what direction is it in? Negative x, right? So we're going to add to that negative 14 meters, but it didn't go anywhere in the y direction. And then, of course, here, from here to here, we've got 23 meters south. So what direction is that in? Negative y. So this is, okay, it's going to be fun. All right, so this is going to be 0 meters and negative 23 meters. And now we can just add them all together to get our resultant vector in rectangular coordinates. And so, let's see, 10 plus negative 14 is negative 4. And then 20 plus negative 23 is negative 3 meters. But now, how far and in what direction? That's polar coordinates. So let's convert this to polar coordinates. So what is r equal to? The magnitude of r. It's use Pythagorean theorem. It's the x component squared plus the y component squared. And of course, everybody's favorite Pythagorean theorem problem, 4 squared root of 16 plus 9. It's 25, square root of 25 is 5. 5 meters. And then for the angle, we have the inverse tangent of the y over the x. Okay, get your calculator out. Now, one thing you got to do when you do this is not take the inverse tangent of -3. You have to make sure that you finish the division, or you put it in parentheses. So let's do this. Turn the calculator on. Inverse tangent of -3 divided by -4. You can take the negatives out because you know they cancel out. So when you type it in your calculator, you don't need to bother. And when I hit equals, I get 36.9 degrees. But what is true? What do I have to do? So that's telling me that here's 36.9 is in this direction, but the angle is actually over here, isn't it? So, and of course my x component is negative, which tells me I have to add 180. So we're going to add 180, and we get, so theta is equal to 216.9 degrees. So you can say vector r, I ended up 5 meters away and at an angle of 216.9 degrees, and that's measured counterclockwise from east, like this. Now if you had said, oh, it's 36.9 degrees, if you're going to use this 36.9 degrees, you got to be really specific. If you had said 36.9 degrees south of west, I would give that to you. Do you see what I'm saying? South of west. Here's west, and we're going to go south of west, 36.9 degrees south of west. That would have worked. I would give you full credit for that. But actually, what I really want is for you to put it in polar coordinates. In polar coordinates, we always say the angle is measured from, counterclockwise from the positive x-axis. So here's my answer, and we are finished with this problem.